Good afternoon, folks. This is Readiness Assessment 5, Part 2. I'm going to start with question number 9. We're going to give ourselves a sticky note so we have a little bit of space to work. So in this one, we're looking for the x-intercept, which is going to be different. Usually we focus on the y-intercept, which is where it crosses the y-axis. But in this case, we're going to talk about the x-intercept. So part of it is just understanding what it is. So if you remember, when we graph stuff, if you have a line, the x-intercept is where it crosses the x-axis. The x-axis is going to be where our value of y is at 0. So you could just get the y by itself, graph it, and see, but sometimes we get fractions or other things. So in this case, we are just going to solve for the x-intercept. And so if I want my x-intercept, I know that my y has to equal 0. So for my equation, I'm going to substitute 0 in for y and solve for my x. So negative 7 times 0 cancels out, just gives us 0. So we have 3x equals 24. Divide by 3 on both sides, and x equals 8. So our x-intercept in this case is going to be 8. Okay, another way that you would write it would be x comma 0 is another way to see it. Moving on to number 10. Number 10 is just saying write the equation in slope-intercept form of a line that passes through the point 65 and is parallel to the given line. So if we remember, if things are parallel, what do we remember about their slopes? Hopefully we remember that they have the same slope. So we're going to take that equation. I'm going to write it over here. X plus 3y equals 9, and I have the coordinate 6, 5. So that's going to be my x and my y we're going to use a little bit later on. So starting off with our equation, we're going to get the y by itself so that we can figure out what our slope is, because if it's parallel, then it's going to be the same slope. So we're going to put my x's first because I want to put it in y equals mx plus b format. I'm going to divide by 3 on both sides, and I have y equals, using our butterfly method, I have a negative x over 3, and then I have a positive 9 divided by 3, which is going to be 3. So another way to write this is I technically have one x on top and a 3. You can put the x on top if you'd like, or out to the side. It's going to be the same, plus 3. So let's make this sticky note a little bigger. So now we know that our slope that we want for our parallel line is going to be negative 1/3. So we want it to be the same. So we're going to say y equals negative 1/3 x plus b. We need to figure out our b. So this is where that coordinate comes into play, where we have that x and our y. And we're going to plug in 5 for our y and 6 for our x. So the nice thing about this is 3 and 6, they go together. If it helps you, you can put it over 1. I'm going to have a negative times a positive, which is a negative. 1 times 6 is going to give me 6. And then 3 times 1 is going to give me 3 plus b. So I'm going to do negative 6 divided by 3. That's going to reduce to negative 2 plus b. To get the b by itself, I'm going to add 2. I'm going to end up with 7 equals b. So our overall equation, we're going to use this slope and this y-intercept. So I'm going to say y equals negative 1/3 x plus 7. Okay, moving on to number 11. It says which of the following equations has a graph that is perpendicular to the line? Select all that apply. Okay, so we're going to need our sticky note for this one again. And remember, perpendicular, it's going to deal with our slopes, but instead of being the exact same slope, our slopes are going to be opposite reciprocals. So starting off, we have x plus 2y equals 14. So we need to get the slope of our original equation. So we're going to subtract x from both sides. We're going to have 2y equals negative x plus 14. We're going to divide by 2 on both sides. And we get y equals negative 1 over 2x. And then we have 14 divided by 2, which is going to give us 7. So that's our slope, negative 1/2. We want our perpendicular slope. And if we remember, it's the opposite reciprocal. So because this is negative, we're going to need positive, and then we're going to flip it. So it's going to be 2 over 1, or in our case, just 2. Okay, so our equation will have a slope of 2. So if it was in this form, it'd be y equals 2x plus whatever our b is, but we don't know what that is. So we're going to use these cases and see if there's anything that has a slope of 2 for these situations that we have. Okay, so if I look at A as one of our options, I'm just going to rewrite it. I want to get the y by itself, so I want it to be positive. So for this one, I'm just going to add y to both sides. So I'll have 2x equals y minus 7, and I'm going to add 7, and I'm going to get 2x plus 7 equals y. So in that case, I have a slope of 2, so A works. But if you remember, this is one of those select all that apply questions, so it means we're going to have to try, because there's going to be some other ones. So I'm going to delete this one. Let's give us a new one. Okay, so we're going to try B in this case. We're going to say 7y equals 14x plus 2. I want the y by itself, so I'm going to go ahead and I'm going to divide both sides by 7. And I get y equals 14 divided by 7 is going to give us 2x plus 2 over 7. I don't really care about the fraction as much, but we see again that we have a slope of 2. So that was our option B. For C, we have x plus 2y equals 7. Now some of you might be able to see it right away, but if I minus x, I got 2y equals negative x plus 7. If I divide that by 2, I'm going to get y equals negative 1/2 x plus 7 over 2, which does not give me a slope of 2. And then lastly, we're going to try D, which is 14y equals 7x plus 2. I'm going to divide by 14, and y equals, looking at this first part right here, I have 7 over 14, which is not going to give me 2. So in this case, I'm just going to end up with A and B. Okay, jumping on to number 12. It says, which of the system of the inequality is shown below in the graph? And so the best way to start this is with our b's. So I'm going to do B for my dotted line, and then I'm going to do B for my solid line. And if you remember, if I have a dotted line, my inequalities are greater than or less than. And if I have a solid line, they're going to be greater than or equal to or less than or equal to. So that kind of helps us to see which one's associated with. So with our dotted line, we see right here that it crosses at 2. And then for our solid line, we see that it crosses here at negative 3, because our graph counts by 1. So for my solid line, I need a negative 3. For my dotted line, I need a 2. So I look here, I have a 2, and I have the inequality that matches. So far, so good. Here I have a negative 3, and I have an inequality that matches. So far, this is a possibility. 2, because my inequality doesn't go with it, B is not going to work. For 2, this one, I have an inequality that works. Negative 3, I have an inequality that works. And then if I look at D, both these inequalities are the same, saying they both should be solid lines, so that one doesn't work. So now, we're going to look and just say, okay, which direction? Because our options look almost exactly the same. So I'm going to erase some of these circles for A and C so we can kind of see it. And if it helps you, maybe I'll go like this so we don't look at these guys. So if you look at A and C, they're almost identical. The only thing different is their inequalities. So this is where sometimes we have a hard time when we don't know, is this greater than or less than? So because this is shaded, dark there and dark here, that means that's where they intersected, both of them. So we're going above the line for both of them. So both of them in this case are going to be greater than. So our inequalities that have greater than are going to be our option A. I want all the y's that are greater than or equal to our line. Number 13, which ordered pairs are a solution? So you can graph this as well if you want. Or you can go through and you can do the algebra and you can plug them in and see which ones work. So I'm just going to sketch you a rough graph. It won't be super pretty, but hopefully we can read it. So my M is 4 and my B is negative 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And this might be nicer for those of you guys that have graph paper at home. Give myself a couple lines here and here. I'll do my best to graph it. So our slope is 4, which means we're going to do 4 over 1. We're going to rise 4 and we're going to run 1. So we're going to go up 1, 2, 3, 4, run 1. Here's our next point. We're going to rise 1, 2, 3, 4, run 1. we're going to rise 1, 2, 3, 4, run 1, 1, 2, 3, 4, run 1. And in this case, because it's just greater than, it's going to be a dotted line. And remember, dotted line means it can be anything above it or below it depending on what it's asking, but not on it. It means it's not included. So in our case, our inequality is saying I want all the y's that are greater than. So instead of using that, let's shade it. That means I want everything here. So let's just plot these points and try it. So A is negative 3, comma 1. Excuse me, negative 1, comma 3. Negative 1, comma 3. And if we see, that one works. That one's in our shaded area. If we go 0, negative 9, that's a nice one, but it's right on the line, so it's not going to work. It doesn't count. Okay, if we look at C, it's going to be 1, 0. And that works. And if we look at D, that's going to be 2, 1, which is also in our shaded area. So in this case, we get everything except for B. Okay, moving on to number 14. It's asking us what's the solution to this system. This one's just going to be a lot of algebra that we're going to try and plug in to see what works. So I'm going to try these coordinates, and remember these are x and y, and we're going to plug them in. Now don't get carried away, but we're going to see if it works for one. We're going to make sure it works for the second one. So I'm going to plug in 6 parentheses. My value of y is 3 equals negative 4 times negative 5, not plus, minus 2. So 6 times 3 is going to give us 18. Negative 4 times negative 5 is going to give us 20, minus 2. So we're going to have 18 equals 18. So far it works for the first equation. And we're going to try our second equation. 2 times 3 equals negative 2 times negative 5 minus 4. So we're going to have 6 equals 10 minus 4. 10 minus 4 is 6. 6 equals 6. So in this case, we got lucky. It was the first one. So if you go through and you try the other ones, and the algebra doesn't work, don't just start switching to signs. Okay, and in this case, it doesn't say select all that apply, so we're just going to stick with that first solution. Okay, looking at number 15, this is going to be our translations that we've had, and you got to just remember, if I have an x plus 2, which way does it move it? Is it going to move it down? Is it going to move it right? Is it going to move it left and down? Or is it going to move it up? So a good way to check it is if you could graph it, and then add 2 to all of them. But in this case, it's going to move our graph up 2 units. All of our values are going to be 2 more. Okay, and then if we look at number 16, if f of x is 2x minus 1, and g of x is that f of x, and then we add 1, what is it going to do? Is it going to be a horizontal translation of 0 units, 1 unit, 2, or 3? So if you think of it in this case, we'll think of what number we have circled. 1. So in this case, it's going to be 1 unit. Okay, number 17 gives us f of x equals 1/4 x plus 1, and g of x is 4 times that. And what's the slope? So we want to just get it to y equals mx plus b. So it's like we're taking this and we're distributing it. Well, the nice thing is we have this 4 and this 1/4. And so if we multiply those, 4 over 1 times 1 over 4, it gives us 4 over 4, which simplifies to just 1. So our slope in this case is just going to be 1. And then number 18, let f of x equals x plus 4, and g of x equals x minus 3. And if g is a vertical translation of f, how many units and in what direction? So think about it. On f of x, our b is 4, and here our b is negative 3. So our b is 1, 2, 3, 4, and 1, 2, negative 3. So I'm saying if this is a translation, how many spaces is this translated? Well, if we look, it's going to be 7 spaces, and we went down. And this concludes Readiness Assessment 5, Part 2.